are going to be moving on in mathematics to double-digit multiplication. Again, you're going to have a rectangular array. That's going to look more like a square, but it's still going to be an array. We're going to break up the numbers into their place values and write an equation that we're going to use partial products, and both the array and the equation must agree. There's a lot of that in 4th grade. So some of you I know are excited to get into larger numbers, and this is the way we're going to do it. This is going to be week 19, and we've looked at single-digit arrays, one number times all the way into the thousands, and you can keep on doing single-digits arrays that way. And we also are familiar with partial product method for figuring out standard algorithms. But now we're going to do double digits. Now these are still going to be arrays, so it's not that we're taking an area model, we're taking an object or something that we're measuring, and we're trying to figure out how much of something it is. And we always start with a single unit. So this unit, I'm thinking about something that we can measure. Let's say it's soup cans. So if you get a job at Walmart and you're putting product out on the floor, they don't count each individual can. They count the area collectively, and the same thing for the soup that's in the back. So this would be an array that they would use for something like that. So let's come up with some numbers. Let's say 42 and 78. Okay, here's two double-digit numbers, and that's our standard way of looking at multiplication generally. Now let's look at how we would solve that using a rectangular array. We'd need a section for each one of the tens and the ones place. So let's just make this look like we're dividing it in half in two ways. We have our addition here, because we're going to use our expanded notation, our base 10 notation for both of these numbers. Now, I like to use this number up here. It doesn't matter which way you do it, but you have to get it in the right notation. I'm going to put my 10s over here and my 1s over here. So here's 78 broken down to its place values. And then for 42, I'm going to say 42. Now you can make this arrangement differently if you want. You can put this up there. You can put your 1s here and your 10s on the outside. But try and be consistent. This is kind of the standard way that everybody does it. But your product, which will be over here, the total number, is going to be the same. So let's see how we do that. If you remember your arrays, and you did pretty well in the test last week, you should have no problem here. This is kind of the tricky one here, and these are tricky, and these are like ones you should know already just from 3rd grade. So let's do the one you know from 3rd grade. We're going to take this 2 and this 8, and they meet in this rectangle here. So we're going to multiply 2 times 8, and 2 times 8 is 16. That's the easy one. So we got one solved. Now this one here is not the 2 and the 40 anymore. We aren't multiplying these two numbers times each other or these two numbers times each other. We're multiplying this number times that number, and we're going to have to do that twice. We're going to have to multiply 2 times 70 and 2 times 8. So we just need to fill in this 1 here with a 2 times the 70. So remember, this is in the tens place. So if you remember your place values, tens has how many zeros? And you can go ahead and write that 0 in here. Okay. Now you're going to find out the value. This is just a placeholder. It has no value. It's just holding it's saying that there are no 1s in the tens place. Now let's go ahead and multiply. 2 times 7 is 14, and we get the number 140. Everybody with me so far? Okay, so this is this row. So let's do this row. We're going to do this one last because this is the hardest one to remember. Let's do this row. Now just like we had 2 times 70, we're going to have 8 times 40, or 40 times 8. Either way is fine. We aren't doing arrays where we're grouping. Okay, in our grouping arrays, our equation has to agree with our grouping. And here we aren't doing grouping. So 8 times 40, we have a tens over here. So what do we need over here? We need a 0 over here. So these two have the same zeros. And then we multiply the values. What's 4 times 8? You should have this skip counting done. If you don't have a skip counting sheet and you don't know 4 times 8, stop the video right now and get your skip counting sheet done. 2s through 10s. I'll wait. Okay, so now we have 4 times 8. 4 times 8 is 32. And this one's 320. Now let's look at this one. This one's a little bit different because we have a 10 times a 10. So if I do a 10 times a 10, what is 10 times 10? Can you tell me? That's 100. That's the last value in our skip counting, 10 times 10. So if we multiply a 10 times a 10, we don't get just one zero, one single place value. We get 2 place values. A 10 times a 10 gives us 2 place values. So we can go ahead and put in our 2 place values here. That is kind of tricky because you're thinking, oh, there's only 1 tens over here. But there isn't 1 tens over here. There's 2 tens. And if we look at tens times tens, we get 100. We get 2 zeros here. Now we can change these values to anything we want, but we're always going to have these 2 zeros. Okay? So now we do our values here, our 4 times our 7 or our 7 times a 4. Again, it doesn't matter because we aren't arranging our array right now. We're just coming up with the amount of soup cans. We don't care how they're arranged just yet. So 7 times 4, 4 times 7 is 28. Okay, so now we know all the different quantities inside our array here. So let's do some column addition. I like to start with the largest number on the top. Okay, then I go to the next largest numbers. And then I go to the smallest number. Okay, since we're adding these on the outside to get our numbers here, we have to add all these on the inside too. Every time you see something like this where there's 2 sides that come together like that, that means we're adding them together. That's what that means. So, addition over here, super easy. Get a second grader to do this. It's 6 here because there's no values in this column. Now we have a 4 and a 1, which is a 5, and a 2, that's a 7. We have, now this we can do several ways. I'm going to take the 8 and the 1 is 9, and then I know this value drops by 1, it's going to be 12. Okay, if it was 10, it'd be 13. If it's 9, it's 12. 12. Oh, 12. I almost forgot about that part. Okay, so did you see that? 8, 9, 10, 11, 12. Normally I could put the 12 right here, but I'm going to carry it in my addition because we're already carrying our numbers in our addition. We're using a standard algorithm like this for addition. We aren't doing it in multiplication just yet, just addition. So 2 plus 1 is 3, and that's how many soup cans would be in an array. That's 42 soup cans on this side and 78 soup cans on that side. Okay, I hope you're good with that. Let's look now at how we do the partial product over here. We're going to use these same values, but we're going to put them in the order in which we do them over here. Pay attention, okay? Watch real close. 2 times 8 is what? 16. There's my 16 right there. 2 times 7, 70, 2 times 70 is what? 140. Okay, I went to the tens over here, 2 times 10, so I had to put a 0 in there. Now I'm over at the tens place here. So I'm just going to go ahead and put a 0 in for the tens place because I'm already here. 4 times 40 times 8 is 320. Okay, and I already have that 0 over there for me. Now I'm going to do a tens times the tens. Remember we said 10 times the tens has 2 zeros? So I'm going to put my 2 zeros in here. And 4 times 7 is 28. Now I have just the opposite, the way I stacked them over here, to the way I stacked them over here. The answer is going to be the same because I didn't change any of the values over here. So let's go ahead and add these stacked numbers. 6 comes right down because there's no values. 4 plus 1 is 5, plus 2 is 7. I got 8 and 1 is 9, 10, 11, 12. Again, we're adding, so we're going to go ahead and do our carrying over. And I get 3,276. Over here I get 3,276. So here's our sample. There's 2 more in here and 3 more in the back. Go ahead and give that some practice. Try to get the correct answer the first time. Have someone check your work, because when you get the wrong answer, you're just teaching yourself how to do something wrong. And we don't want that kind of child or student going around doing the wrong things. We want you to do the right things. So this will be in your package along with 2 examples over here to follow and a few examples in the back. Practice. Make sure you turn in your packet on Friday.